Okay, so one of the important skills you will learn from my class is to use a financial calculator. And we're not talking about just multiplication, addition, taking powers. We're actually talking about time value of money solving, net present value, internal rate of return, and all these statistics functions offered by a Texas Instrument calculator. You could have an 83 model or 84 model. So right here, my demonstration is showing you I'm using the electronic version of an 84 model. Okay, so if we look at the exercise I posted on the Canvas, there are two files, and one is exercise 1 chapter 5 and another is exercise 2 of chapter 5. And we're going to go through them in class. And here, just for you guys to completely understand how to use a calculator, I do this recording. So let's first just look at question number 1 of exercise 1. How much would a $20,000 deal in 50 years be worth today if the discount rate were 7.5%? So from this question, you are basically solving for a present value based on a future value of 20,000. You see, this 20,000 is a dollar figure 50 years later, okay? And you want to know its present value today. All right, so the interest rate is 7.5%, and the number of years is 50. So what do we do here? We first need to click apps, and then you see finance, and you just hit enter, okay? And you see time value money solver, and hit enter again. And that will lead you to this page. And you're going to define N as a 50. I, you see the rate is 7.5%. And very important, you are going to put a 7.5%, all right? You do not put a 0.075. You don't put the numerical format. You just use the number portion of that percentage. Okay, that's very important. And then you are solving for present value, and the payment is 0 because there is no periodical fixed amount of payments, either received or paid. And then the future value is $20,000. Okay, and then you are going to solve for the present value. So you move back to present value, make sure this is highlighted, and you are going to hit alpha, enter, okay, alpha, enter, and then the number shows up. It should be $537.78. Okay, one thing is if you want to get to the final answer, you not only need to hit enter, but also alpha. You see the solve word solve is right here. It's in the green color. So that means you need to hit this green button and then hit enter to get this solve. And the second thing is the present value here is negative because your future value is positive, so your present value has to be negative. It's like you are depositing $500 today, okay? So that's a cash flow out of your pocket, okay? You put it in a bank or in any financial institutions, so that's a cash outflow from you. And then 50 years later, you're gonna receive $20,000, and this $20,000 is going to be a cash inflow, okay? So money out, money in. That's how we do this question. So the answer for this one should be E, okay? And you can do the other ones based on this skill. So now let's look at a more difficult one. And this is on the second file of the exercise. And I want you guys to take a look at question number 2 here. So basically, I give you a picture, and that shows you the financial terms for a mortgage. So basically, your purpose here is to verify this number, 1951, okay, as a principal and interest. And that's basically your monthly mortgage payment, okay? That's your monthly mortgage payment. And the price you pay is $399,808, okay? So that's the house you buy, and that's the price of the house. And you are making 30% down payment, okay? And 30% of this 399,000 is 119,000. And you have also these terms, which is 15 years, and the fixed rate is 3.138%. So you have 15 years to pay back the loan. and the interest is 3.138%. And no matter how large or how small this interest is, it's always an annual interest rate. Okay, it's always the annual interest rate when it's provided to you, unless it is specifically mentioned. If I say the monthly rate is 0.1%, then that's monthly. If I say this interest is 1%, then that is a annual rate. Okay, so now let's try to do the work. So on the calculator, we are going to put all the numbers in the right place. So first of all, the number of periods is 15. And it is very important. We have 15 years. And is that our total number of periods? Well, the thing is, your payment is made on a monthly basis. It's not made on an annual basis. Therefore, a lot of things are going to change. So first of all, the number of periods, the n here is not just the number of years. It should be number of periods. Okay, in each period you make one payment, so you should put a number of months here instead of number of years. So what you do is after you put in 15, you put a multiplied by 12. Okay, and then you move down. So the calculator will automatically compute it for you. You have 180 months of payments in 15 years. And next is about our interest. Our interest is 3.138%, and that is an annual interest. So you need to convert it to a monthly interest by dividing the annual rate by 12. Okay? And then this is your monthly interest, 0.2615%. And then the present value is how much you are borrowing from the bank today. All right. So when you buy the bank, you pay this full. When you buy the house, you pay this full price of 399,000. Okay. The thing is, from a bank, you're not borrowing 399,000. You only need to borrow part of the house price because you have already paid the rest in down payment. All right. So assume you already have some cash in your pocket. So that is 119,000. Use that as a down payment, and then you borrow the rest. In other words, you are paying 30% and borrowing the rest is 70%. So the amount that you are borrowing is 70% of the price. So you can use the 399,808 times 1 minus 0.3. Okay, and the 0.3 is a 30%. That is the amount or the proportion of a down payment of the full house price. And be careful, I did not put a number 30, but I put a 0.3. Okay, you have to do 0.3 instead of 30. For interest, for 30% interest, you have to put a 30, okay, not 0.3. And the interest, for interest, we're gonna treat them differently. And then we move down, we're solving for payments. And for the future value, we're gonna leave it at 0, okay? We're gonna leave it 0 because there's no one-time lump sum payment received or being paid 15 years later when your mortgage is paid off. So future value is 0. Okay, and then we move back to payment. We do alpha, enter, so solve. Right here, that's my payment. So I'm going to pay $19.51 per month. Okay, for a mortgage loan of $279,865. Okay, so basically that is consistent with the result here.